Hello and welcome everyone to today's webinar. We're happy to have you with us. We have today Anthony with us. He will be our speaker. We will cover database designs and SQL. So let me present myself. I'm Slim. I one of the co-director at Social Hackers Academy. And at Social Hackers Academy, so our mission is to make education accessible to everyone, tech education in particular. And right now we are teaching full stack web development and blockchain development. We started, so SHA, shorthand for Social Hackers Academy, is a Greek NGO. And we started operating offline back in 2017. And then with the COVID and the pandemic, we switched to the online model. So everything we do is fully online. And that actually helped us. It was a good thing for expanding our reach and to support more people do changes in their career. So yeah, and that's about us. Today we have Anthony, so thank you for joining us, Anthony, and for taking the time. And if you want to present yourself also to the audience.
All right, thank you, Slim. Hi, my name is Anthony, and I'm a full stack developer with over 11 years professional experience, and worked in different countries across different organizations. And currently I'm in Germany now. I work as a software engineer for one of the startups in Germany. And I'm also an author. I just wrote a book, I think it came out early this year, for React.js design patterns. So that's all about it.
Nice, that's amazing, Anthony. And you write a book about React.js design patterns, right? If
Yes.
I understand well. And is it available? So
yes, it's available. It's on Amazon.
Okay. So we will make sure to put the book in the description. So the event is being recorded actually. And you can watch it again. It will be uploaded on our YouTube channel tomorrow. Yeah, so Lori said thank you, Anthony, for joining us from the chat. And yes, actually, Anthony, for your presentation, would you like, how do you prefer we do the question? Like if the attendees have questions, do you prefer to get them as we go, or do we keep the questions to the end of the presentations?
So whichever works for them. I think because people can forget the questions they want to ask at the end of this the event. So I feel they can just drop the questions. So maybe I could answer them later, or I could stop and answer, but I prefer to answer everything at the end.
Yeah, that's what I meant. So for people to ask their question when they have the question, not wait till the end of the presentation, but for answering them, so we keep them at the end, right?
Yes.
Okay, great. So okay, thank you, Anthony. The floor is yours.
All right, thank you. Just going to share my screen. So today's topic, actually, like Slim has actually mentioned, is database design and SQL. And I'm just going to start with, okay, basically we've been hearing there's a database, everything comes from the database, Now, what is this database? Now, I can say a database is a collection of structured data or information that are usually stored in an electronic form stored electronically, it can also be defined as a place where data is stored so it can be retrieved and updated. Now, there are different definitions of this, but it's all about storing data and retrieving. Now, it could, the word database, it's usually is referred when we use it in terms of software development, but it's not just stored electronically. So, there are times we keep manual records. For example, in our nursery schools, you could have a student register. So you have all the names in the class, and every day they come to take attendance. At least back home in Nigeria, that's what we usually do then, but things have actually modernized. So we keep that record, everybody's record, and we keep ticking for the days you came to school so that we know the days you were absent and the days you were present. That can also be called a database. But database these days are for data, they're usually stored electronically. Now, we can take an address book, a mobile address book. So all of us have phones and we have a contact list and we can store data there. So you can store in name, the email, sometimes you can store the picture, you can store the ringtone, you can even write a small detail about the person that has that particular number. So you can store thousands of them. That is also a database. Because if you look behind, it is stored, your database is stored most times on the phone. And that is why when you lose your data, when you lose your phone, you're able to actually retrieve that maybe from your Google backup or maybe from your iCloud, because these things, they synchronize. So it's locally on the phone, it's a database, but it can also be stored electronically, online in the cloud. That is where Google comes in. Now, to actually know, there are different types of database, right? There are different types of database. Now, for this session, we're just going to be talking about the two most important ones, relational database and non-relational database. Now, we can say that relational database is actually a database that has relationship between two entities or tables. It could be two or more, but I just limited it to two. Now, these entities are called tables also. And examples of such database, there are more, but we just limited it to MS SQL, Postgres, and Oracle. And these databases are made up of these tables are made up of rows and columns. Now, these columns have the data type. They have these columns have it's more like a key value. So it has your data name, that's a column. So if you look well, you can see we have ID, name, mobile, and email. Now we have a data type, which is the ID is an integer, the name is a string, the mobile is varchar, and the email is character. So it says there that the ID can only accept integer. So if you try to input a string into it, there is a very big problem. It will throw an error. The name can accept a string. The mobile, a varchar. So now varchar comes from the data type in MS SQL. So I just mixed them so that you don't get confused. Then email is character. Character comes from Postgres. String also comes from Postgres. Now, each of these tables have a unique identifier, which is the primary key. Now, why this primary key is necessary is because it keeps track of every record that goes into that particular table, so that we can use that key to actually retrieve data easily, to actually do our CRUD operations. Now, that primary key is unique. You cannot have two primary keys in one table. It's not possible. So what you can have is one primary key and you have unique identifiers. Now, all those the unique identifiers are maybe something like email is a unique identifier. not because I cannot have two emails, same email inside a particular table, right? If I try it, if I make it a unique key, it means that whenever I add, let's say johndoe@test.com, if I try to add it again, even if other details are correct, including the ID, which is the primary key, that is going to have an issue. So this is good when you want to actually build a very, very large application. Now, this application, if they are going to have relationships between one another, so you have, let's say you have an address book now, right? A contacts table, and now you are going to have, let's say you're going to have something like countries. So we can add a country ID here. So we can have a country or nationality table that has all the nationalities. Now, for me to actually reference that nationality here, I'll come and put something called nationality ID or country ID that I can actually use to make reference to that table. So for easy retrieval. And again, this primary key, the primary key, you could make it auto-generated. Usually, most of the relational database, I know of MS SQL, Postgres, and Oracle, these are usually done as identity. So what it means is that when a new record enters the table, they are auto-generated, right? It could be, you could start from 1, you could start from 100 as a primary key. So it keeps increasing as you add records to the table. For non-relational database, they have no tables or columns or rows as compared to the relational database. Non-relational databases are used to store data in documents formats, usually JSON format, and they are mainly key value pair. Examples of such databases are MongoDB. Now we're going to look at an example for this. Now, you can see that the key, it has a key and the document. Now, the document is a JSON format. You can see I tried to create what we had there the same way. We have the ID. So let's say the ID is, it depends on where it's coming from the front end. You could give it any ID. It has the name and it has the mobile. Now, the key here on the left-hand side is the unique identifier, actually. So if I try to retrieve this document with 1, 2, 3, 4, 5, I'm going to get this document. So if I put the key 1, 2, 3, 4, 5, I will get this document retrieved to me, and I can actually view it. So the difference is that this is not structured, right? Non-relational database, they are not structured. Relational databases are structured. Now, it depends. Now, when you want to choose either of the databases to use, it depends on what you are working on. It depends on your project. It depends on where you see the data growing to, right? For this, non-relational databases are faster to retrieve data because they are not structured data and they are stored as JSON, is a document, right? So if you work with a little bit of MongoDB, you can see that it's usually fast, very, very fast. And that's what they use for most of these applications. Most of these applications that have so much data, they actually go down to use such relational, such non-relational databases. So like I said, it depends on what you are working on. You cannot sit down and say, okay, I think it's easier for us to use a relational database. But you'll find out that when you are writing the dates, when you're writing maybe your code or you're building your application, you now run into some serious challenges. So I always advise that you take your time, understand the scenario before you pick a database. Something called SQL. Now, SQL is known as structured query language, right? It's like an English like syntax, which is used to interact with the database. Now, there are 4 major statements of SQL used when interacting with database. Now, this statement includes the create, the read, update, and the delete. Now, this create, read, update, delete, you would usually see them, you usually use them in the database, but you don't have any statement like read. There's no statement like read in your SQL statements. There's no read from, no. It's usually a select. Now, the create is when you want to insert, when you want to create a database, when you want to create a table, then you want to insert a record. So you are creating something, you are creating a new record, you are creating that table, you are creating that database. Another, for the updates, yes, you usually updates when you want to make changes to the database, or sorry, maybe you want to make changes to the table. Now, there's also something called alter. That falls under update. So let's say I want to alter a table. Maybe I put a table, I want to alter it from maybe the data type. I want to remove it from integer to Boolean, right? I can actually alter, I can say alter table, whatever the thing is, and I can alter that column. Or I want to add a new column to an existing table. So it's going to be alter table, then I add whatever column, give it this data type. So that can also fall under updates. Updates could also mean I'm updating, I want to change my name, for example. Let's say I have a name in my contacts. Now, we're still using the contact table. I have a name, let's say my name is Anthony. So I want to change it to Okonta, which is my surname. I will just use that update to actually update that particular set. Usually it goes with a where clause. Then the delete actually is to remove a record, right? And that delete also goes with a where clause. So we'll actually look at this in more in details in the next slide. Just wanted to give also a preamble of what we are going to see. Now, so you can see that the create is used when we want to create a database or table, or even add a new record to an existing table. Let's look at the above 3 scenario with the contact table, which we looked at in the previous slides. Now, to create a database, the syntax is to use is create database, then the database name. So in this case, we're going to say create database address book DB. Now, it differs from organization, and it differs from the way you name your tables. But it's advisable to actually give it the name of the database, then you add the DB. At least, you know, it's a familiar format, because when I see this name address book DB, it clicks in my head that, oh, this is the database, right? At least it's just giving you is a good naming convention. So always try to keep that in mind when you are designing yours. Just say maybe whatever name you want to give it, then add DB. Now, after we create the database, we need to add tables, right, to house our contact details. Now, to do this, we can simply run the create table TBL contacts. Now, again, the TBL varies from organization to organization, or for person to person, depends on how you want to name it. Some people just name it contacts. Some people name it contacts table. But in most books and a standard format and a standard convention is to name it TBL. TBL means table contacts, right? And we can see that you put then inside you have the column and the data type name here. So in this case, we have the ID. Now, The ID, the first thing you put inside a bracket is usually the column name. So here we have ID, and it's an integer, right? It's an integer. So it could be ID, varchar, depends on you. Now I'm specifying that it's a primary key there, and it's not null, and the identity is 1,1. So I'm going to explain this. This identity 1,1 is usually done with MS SQL Server. I just put that there so that you have an idea of at least how it works, because most of the relational database you'd see is inside the top 2. MS SQL is usually mentioned, right? Because in Microsoft, you know, more of Microsoft. But when it comes to other databases that are usually open source, that are relational database, it's usually mentioned as Postgres. Postgres is the one that is actually mentioned. And so the identity 1,1 means that when you insert a record into this table, right, it should start from 1, insert another record 2, so it's incrementing by 1, right? So if I put the 1,2, it's going to be 1, 3, 5, 7, like that. So it depends on the format you want to use. Then we have the name, which is varchar, then the phone, which is varchar. Now, the varchar, and you see in the parentheses 20, it means that, hey, the name should not be more than 20 characters. It should not be more than 20. If it's more than 20, it's going to throw an error. Even if you satisfy the whole conditions of that particular table, it's going to give you an issue, a serious issue at that. So this is just to say, hey, I cannot take more than 20 characters, because I don't know why you have, so your name, please shorten it to have 20. Your first name, last name, middle name, and your alias, please, should be 20. Now, the phone that is having a varchar without a parenthesis of 20 means that you have an open-ended character, which is not too good, except maybe you're storing something like an address. But even an address, we usually say, maybe, I don't think anybody's address is more than 100. We'll shorten it. And that's why you see most times in application designs, they say states or country, states, streets, zip code. They're just trying to shorten it, at least give you, so that there's an aggregated there's a format. Because if you leave it open-ended, people will write a whole lot of things. I can just go online and I will just copy something on Wikipedia, I will slam it as my address, and it goes into the database. When it goes in there, it becomes difficult for me to retrieve data. So let's say I want to do a select all from, let's say I have 1 million records, and I want to select all. I want to select the 1 million records. With that thing that I have done and put a length that is unimaginable, let's say if a character of 4,000 words, the database begins to slow. It begins to slow down for that particular row, because imagine we have 1 million records and we have 4,000 so inside that disk space. So mind you, we are actually having a disk space. You put 4,000 words inside phone or name. It doesn't make sense. So when you continue going like that, it becomes a problem. So those are one of the things you need to consider when you are designing your database. Always try to make sure that you limit the person. And it's also better that you actually have, if you're using a relational database, please always try to make use of your primary and foreign key. Because now because this primary key now is a unique identifier of this table. Like I explained earlier, you could have a nationality or a country's table that has an ID. You can actually reference it here. That becomes a foreign key. This ID here is a primary key, but this ID can be used somewhere again. Referencing this table, it becomes a foreign key. So that is the main that is the difference. The primary key is for the particular table, but when it's used in another table, it's called the foreign key. So this is basically to create this table. When we do this, our table is created. And so for the read, now, like I said, read is for pulling data stored on the table when needed. It's usually done from a select statement. An example of such statement would be select all from TBL contacts. So this select all is select star. Actually, the all means the all here is a star. So from TBL contacts. So when I pull it, when I run this code, it says, hey, please get everything for me on that particular table. Everything that has been stored from inception on that particular table. Maybe I want to use it to, for some record manipulations and all sorts, but I just need everything that has been stored here. That is when we use the select all from TBL contacts. But what if I want to select records that meet a particular condition? So I want to select people from Greece, for example. So let's say we have Greece as we already have it, people that save their data, their nationality with the ID. Maybe Greece has an ID of 10, right? And I want to now see all the contacts we've saved that have people located in Greece. So what I need to do is I will just do a select. I can do a select all actually, right? Then I can now do a join, right? I can do a join with the nationality table where the ID, the ID that has been stored here, the country ID that has been stored here is equals to the ID of Greece over there. Then I pull everything. That can also be done. That's also some conditions. That's where conditions are. So we can go deeper and deeper and deeper in this whole thing, but because this is just a very, very beginner's course, so we don't want to go too much into it. So, but this is just to show you how the select works when you want to retrieve from the database. Now, for the updates, right? Now, update is for making changes to records in the table, which can be followed by a where condition if it is specific records you want to change. An example of such statements would be update TBL contact set name is equals to James, where ID is equals to 1. Now, the set means the specific columns I want to actually update, right? So let's say, of course, we have name, we have phone, we have, yes, we have name, we have phone, let's say we have email. I can specify all of them with a comma. So I have name is equals to James, phone is equals to 1, 2, 3, 4, 5, 6, 7, 200. And let's say I want to update the email. Now, the where ID is equals to 1. Remember I said that the ID is a primary key and is the unique identifier for that particular record. So I just want to update this particular record in table contacts. So when I do this and run this code, it's going to actually update. So if I don't put the where ID is equals to 1 and I run it without that, I'm going to cause a big problem. So it's going to update everything. It's going to update all the names there to James. Everybody's name is going to be updated to James because there's no where condition. And I've actually, in my 11 years career, I've actually made this issue. This is a serious issue, actually. I've done it like 2 or 3 times. You're not conscious sometimes because of timeline, and maybe they say, hey, you need to speed up things. And it was crazy. The last time I did that back in Nigeria, I was working in a bank and actually did this because of pressure. It didn't end well. Luckily for me, there was a backup. So we just had to delete some records and actually come back to telling the customers to actually push those records again. So it's always important, before you do an update, take this from me, before you do an update on any table, try to put a where clause first. So you can write update where, you write your where first before you write your update statement, so as to avoid what happened to me. So this is one thing I tell people, please always write your where before the update statement. So to avoid some drama. Now, if we do a where ID is equals to 0 or is equals to 200 and that ID is not there, it's actually going to return no record, because that ID, like I said, the ID is that unique identifier. If it's not there, there's nothing that is actually going to happen there. So you are just going to get maybe an error, but you won't try an error. You just say zero number of rows affected, because when you run this update, it shows you all the rows that are affected. So let's say you run this should update and say 1 row affected, shows you that the query was successful. If it says 0 rows affected, it means that there's something wrong with your where clause. So that is one thing that you should also know. So the above code updates the name column from the previous value to James, where the corresponding primary key is 1. Now we have the delete. Now the delete is when one wants to remove a record from the table, and is usually accompanied with a where clause. An example of such would be delete from TBL contacts where ID is equals to 1. So I want to remove the record that has ID 1 as a primary key. When I do this, it's just going to remove just 1 record, because that is the unique identifier for that particular row. So, but what if I now want to remove everything? There's nothing like delete all. Rather, what you have is you want to truncate that table. So you usually truncate the table, whatever, the name of the table. So it will actually delete all the records. Like it starts from scratch again, your table. Like you are wiping, you want an entire fresh table, you want to take out everything. You use the truncate. But when you want to delete specific records, you could do delete from TBL, whatever, where ID is equals to 1, or you can use it. There's something called an in clause. So let's assume you want to delete 1, 5, 7, 10. You want to delete records with these primary key IDs of 1, 10, 15, 20. So what you just need to do is delete from TBL contacts where ID in. Now that in is when you have more than one records you are targeting. If you're targeting 1, it's just where is equals to this. But when you have multiple, it's going to be in. It also applies for the for the update also. In, you can specify X number of IDs or X number of names you want to do, whatever you want to do there, you can use that in. Then you can also do a multiple where, so you can say where ID is equals to 1 and name is equals to 2 and phone is equals to 3 and whatever. So your X number of AND statements, right, would be run. So SQL is going to go to a database with your multiple where clauses, right, with your AND statements that are joined together, check for those conditions and actually delete that record. It goes the same way for update. It goes the same way for reading. That's for selecting. So these are these are the ways to actually perform CRUD statements. Now, this is the basic because SQL goes beyond this. So for time and to limit this session to the very early beginners, we decide to make it this short, at least to give you an idea of how to actually design a database. So these are just the few, this is just an intro. But when you go deeper, so you have, like I said, you have things like alter, you have things, that's when you want to make changes to your structure, or you want to add, when you want to make changes to your structure, you want to add a new column to it. So I think at this, so these are just the basics, please. Always remember your takeaway from this course, even if there's nothing. Always try to write your where clause when you are doing an update, because it's a dangerous thing. You can forget. Please, I always say this in every time I speak on SQL. Always have that where started first before your SQL statement. Thank you. Yeah.
Thank you very much, Anthony. So we kind of covered like how to create a database and the conventions, how to create tables, and how to put records, and how to manipulate also records using the CRUD operations. Yeah, the where statement, if you are going to mess up a database of a banking system, that's really important, like to not miss. Even though I would like to be a customer of that bank when kind of error like adds money into my bank account, but it won't happen soon, I guess. So yeah, I'm checking the Q&A. I think there are no questions so far. So please, if you have any question, you can drop it in the chat or in the Q&A section. But I think it was straight to the point, like the basic operation that we can perform with an SQL database. And here I think we have our first question. So Rachel is asking, are there ever any instances where structured data can be queried using SQL?
So now that's a great question. Yes, it's the same SQL you use. Like I said, remember you are actually doing your, so if you have a MongoDB, you know, you have a key, like I explained in one of this, in the slides, you have a key and a document. That key is a unique identifier, right? So when you get that key, right, when you use maybe, when you get the document, you can actually manipulate your data. You can still use it. It's going to be the same select statement. You are using the same select. You are still going to use delete. Now you're going to use an update statement in the unstructured data. Sorry, you're going to use an update, the update statement in an unstructured data. Using that where ID, where the key is equals to this to update it. So it goes there and updates that document for you. Right? Like I said, the unstructured data, it's a JSON. So if I'm sending the JSON to update, I need to just find a where clause. Like I said, always use a where clause, except you just want to mess the whole thing up. So when you use that key, you can actually update. So you can use your SQL for the No SQL database. It's the same thing. It's just the way they are being stored. One is stored in a relational way and they are stored in tables. The other one is stored as a document, but it's the same SQL statement.
Thank you, Anthony. I hope your question was answered, Rachel. Then we have another question from Carlos. What are the specific cases where SQL is better choice than No SQL databases, if any?
Yes, so please, they are both SQL. I think what you wanted to say is what relational database against no non-relational database, right? So it's when you are building some applications that have multiple users, concurrent users, and transactions going on, right? So let's assume we have, so for example, let's take something like Twitter. There is no way Twitter will be using a relational database, except in some cases, or Facebook, because you have so many things you are storing, so many things that are going in. So you need to actually use that kind, you actually need to use a NoSQL database, a document, so that it's easy to retrieve data. It's easy to retrieve. It doesn't have issues when you're saving it. Now, the problem with most relational database, you can have something called a database lock. When you have concurrency and it's not handled well, there's something called a database lock. It will just lock. So it's best to actually understand what you are doing. Depends on how the data, is it going to be having so much data stored? Is it going to have too many concurrencies? In banks today, you hardly find any bank using a NoSQL because banks are not doing something big. And, Microsoft and Oracle has actually sold licenses, and banks these days, because of money integrity, they always like to focus on people with names. Nobody's going to focus on MongoDB that is an open source. Everybody likes to focus on like all these established names so that in case there's an issue, you can actually come to meet them, right? But like I said, it depends on whatever project you are writing. Again, if you're writing something that's going to have too much concurrency, like you're going to run in so many things, retrieving, you need it up and running, please, it's best to use a NoSQL, such as MongoDB. And again, for license, everybody considers cost. Relational databases, apart from Postgres, you must pay. You must pay license. But for MongoDB, it's actually free. People just use the database as they like. So that's another thing. I know you can consider cost when you're doing all these things.
Yeah, there are many things to take in consideration while choosing the database that you want to use, and one of these parameters to consider are the costs of your of the technology and the tools that you are using. Thank you, Anthony. So then we have Daniel asking, how do we deal with unique IDs and data types when migrating data? So
yeah, so when you're trying to do database migrations, right, you need to consider creating like for like table, right?
creating,
So when you're doing migrations, you're migrating data from one table to another, or from one database to another. It's best that your destination table mirrors your originating, like where the data is coming from, so that you will not run into issues. Because when the IDs are unique, like I said, you have unique IDs. I think maybe he's still talking about maybe primary keys, which are unique also, or
I think so. And sorry, Anthony, and I think the question is, and maybe answer us in the chat, Daniel. I think the question is maybe migrating from like the data you have from an SQL structure to a no SQL structure. So what to do with the keys and the IDs? So yeah, that was his question. So the question is migrating not from an SQL to another SQL database, but to another no SQL database.
Okay, so in that case, right, so you need to, so your primary keys, right, your primary keys in your table, in your SQL table, will be your keys in your No SQL. Then the remaining data would now be in, you can still keep that primary key inside the document. You know, the document is a JSON format. So that particular row, you can convert it into a document and actually store it like that. So that's the best way to do it.
So it depends on the structure of the database you are migrating to use the data that you need. And maybe if you don't need to keep, let's say, the primary keys or data types, because for example, for NoSQL, it doesn't ask you to set the data type from the very beginning when creating the key. So that's a piece of data that you won't need anymore when migrating to the new database, I guess.
Yeah.
Okay, thank you. And then, yes, so what data type can we use in storing images?
So it depends. Now, images, I always like going with No SQL. But in case you are going with relational database, it's advisable to store the data, the images in an image drive away from your database and just use the ID, so that when retrieving, you use that ID to go and check your drive and pull data. Because if you store it like that inside, you run into serious problems. Only maybe you have 1,000 records, your select statement, your database will be lagging. So it's best to actually store it. You can say an ID, maybe picture ID. You store it. You have the picture ID and you store the picture somewhere else. But some people these days, they do binary. It all depends on how large the binary is. If you have a very small picture of maybe, let's say base 64 string of 20 characters, let's say it's just a passport, you can actually store it inside your table. But if you have something that is so large, it's advisable to point it to a document drive that you use that ID to go and retrieve it whenever you need it.
Thank you, Anthony. So I think that was it was the last question in the Q&A. If you still have any other questions, please drop them. Otherwise, I think that's it for today. And thank you again, Anthony, for taking the time to join us today and discuss the NoSQL database design and so on. And thank you all for joining us. I hope you enjoyed today's webinar, and see you in our next webinar. Thank you very much.
Thank you. Thank you.
And have a lovely evening.
All right,
day, wherever you are.
Thank you. Bye-bye.